Okay, having covered the Arduino code, bash script and screen integration, I'll now focus on the physical design. This is the hardware that brings the smart lock to life. This segment will showcase the components, their connections, the innovative features like event logging, and the watchdog timer, meeting the assigned requirements for the physical, creative and reliable system, and etc. blah, blah, blah. I'll walk through the setup and demonstrate it in action, and then I'll highlight how it ties to the project's main goals. Starting with the components. The Arduino Uno is the brain, handling inputs, outputs, and serial communication with Linux. And the servo motor over here acts as the lock, rotating from 0 degrees, which is locked, and 90 degrees, which is unlocked. The PIR motion sensor, which is over here, detects motion, lo and behold, for security alerts with a 3-second calibration for stability. And then the OLED, which is just down here, it's very sensitive, so I'm going to be careful. It shows pin entry, status, and alerts via I2C, replacing the schematics LCD. The buzzer, which is over here, just in the middle, provides audible feedback like 200 millisecond beats for lock actions. So if I type in a lock that's wrong, that's 200 milliseconds, but then motion detecting, slightly shorter. The red and green LED is pretty self-explanatory. On pin 3, we've got the green LED, which is for unlocked. Pin 4 is the red LED, which is locked, so it's currently locked. In the serial monitor, you can see the recent happenings. So motion was detected. I'll get more into that later. We've also, of course, got the push buttons along the side behind here. These are forming the keypad for pin entry, connected to pins 5, 6, 7, and 10 down here. Those are the purple wires, which is excellent. The resistors are pretty self-explanatory. The internal pull-ups, simplified button wiring, and so on, so forth. The connections, it's a little bit difficult to show given the mess, but the wiring is designed for to be as straightforward as can be, right? I haven't done anything special. Let's look at the motor, for example. It's not got any wires, it works fine. You just connect it in, goes to ground. The PIR sensor over there, again, it's very much the same. The signal from power, pin 9, there's no resistor because it works fine from the 5 volt and then ground to ground. And then the buzzer has a positive to pin 8 and a negative to ground, very simple for non-blocking tones. The LEDs, green LED, which is red LED, which is pin 3, and green LED, which is pin 4, each use 2200 resistors to ground, with power capability for future dimming if that's what you like. The push buttons are connected to pins again 5, 6, 7, and 10, all grounded using internal pull-ups in the code to save external resistors. The 200 millisecond debounce ensures reliable input, which is all good. The OLED display, which is down here, we've got the 2 signals connecting over the very end, and the power is connected to 3.5 because that was the only spare one, and ground. But yeah, now I'll run a quick physical demonstration. So it locks out after 3 attempts, and at the moment the default code is 1, 2, 3, 4. So I'm going to enter that here. 1, 2, 3, 4. It enters, the green LED lights up, and it now displays pin accepted, status unlocked. If I were to get that wrong, 1, 2, 3, 4, it says pin wrong, status unlocked. So that's all good. The server rotated, which is what we want, and if we wanted to lock that, we would come over here to the message, we type in lock. We could do this from Linux as well, and now it is locked again. To demonstrate further, if I get it wrong 3 times, so I'm going to enter the pin now. 1, 2, 3, 4. You can see it's entering with asterisks with the underscores. So wrong pin, that's 1. Again, the buzzer goes off. The thing doesn't rotate or anything. And that's the 3rd time. So the security status is now lockout, and we can no longer press the pins. They all do nothing now, which is pretty sweet. You can see the command is locked, and now the security lockout is active. And if we type unlock, It does still work. That's something I want to fix, but for demonstration purposes, it's still very cool. So now it says it's unlocked again. Buttons still don't work because of the security lockout, which just finished just now. And it tells you so in the security lockout. We can also look at stats, type that in here. And now it tells you it's detected motion 3 times, it's unlocked twice, it's failed 4 times, and the uptime is 665 seconds and going, which is pretty neat. But yeah, what you hear down here, is the event logging system. So it stores, if I go get underscore logs, there's the command there, hit enter, there we go. So that's the event logging system. It stores the last 5 events in a circular buffer, which is visible from the command. It adds traceability for security auditing. The watchdog timer that I talked about is an 8-second timeout, which resets Arduino if it hangs. This ensures reliability in real-world use. That's what I was thinking about for that. The security lockout, which I just demonstrated, was a 30-second timeout. It adds robust protection, and it shows, as I showed, it shows up on the OLED as well. I've talked about EEPROM storage before as well, which persists pin settings. So if I type in, I'll show another command too, which is help. It shows all the different commands that you can run. And the one I want is set_pin. So if I type in set_pin, I need to click the box. Set_pin, and let's go 4444. It now says pin changed and saved being the keyword. So now we'll lock it again. It's locked, red LED comes up, the door is now locked. I type in 1, 2, 3, 4, and it's wrong again. That's because it's been changed. I type in 4, now it's accepted. Ta-da! Pretty cool. And this persists across cycles. So if I powered it off or reset it, etc., it would remain because of the storage. Challenges, there was a number. Okay, there was a lot. While I was recording this OLED died on me, sort of. It just went black. And I walked through all of the troubleshooting you could possibly think of. I thought it was the watchdog timer at the start, so I commented it out. It still didn't work. I thought maybe EEPROM storage got corrupted. I cleared it, still didn't work. I reseated the wires. I closed this, I unplugged this. I turned it off and on again. Nothing worked. I tried it again, plugged it back in, and now it's working. So that's wonderful. Nothing changed. It's actually a wonder what went wrong to me still. It is actually beyond me. Moving on though, wiring the OLED was sort of tricky, but the code that I added, which is fallback, which is the display available after initialization failures, it ensures the system functions regardless of whether this fails. And this failed a lot. So that was a lifesaver. I've talked about button debouncing again, so that was critical to prevent false inputs. The servo signal needed a resistor for stability at first, but now I'm finding it's quite fine. The green LED is quite dim. That's something I want to fix as well. But yeah, that's the physical design of my Arduino smart lock system. The hardware, that's the server, the motion detector, the OLED, the keypad, the LEDs, the buzzer, creates quite a compact and reliable and interactive system, I think. Features like, as I've said, event logging, the watchdog timer and security lockout push it beyond the assignment's minimum requirements for hopefully a high distinction score. And yeah, I've combined the code with the Linux integration, and this completes the project demonstration. As always, I welcome feedback and I look forward to hearing it. And thank you very much for watching.